Hi, I'm taking Paul McQuarter's AI for Everyone lesson. We're on number 22 and uh, making face bounding boxes using media pipe. Um, Paul showed us how to do that today, and our homework was to turn that into a class like we have been doing for the other media pipe things that we've been doing. So we'll got my homework done. Figure I'd show you what I got. So I've been putting my classes in a module called MP Helpers, and um, it seems to work out pretty good and keeps them separate, and got quite the list of helpers in this module so far. So it makes the other main code a little cleaner. So with this, we're doing the just replacing what Paul was doing with using our face detection and our drawing utilities. We're putting that in our initialization. We're just, when we initialize it, we don't pass in anything, so we're good there. That's our initializing the class for instances. And then one of the methods we only have one method called get face BB or bounding box. And we're passing in the frame, and we're passing in a Boolean for whether to do the internal drawings that the MP Solutions does. So that can either be true or false. When we bring our frame in, we use frame.shape to get our height and width of it. Make sure we using the right height and width there. We're creating our RGB frame, getting results with our face.process, and we're going to create a list, bounding box, face bounding box, my face bounding box list. And we're going to go through the results, and if we have results, we're going to work through them, each set of faces that we come up with, and we're going to put them into an array. And this couple lines here tells it to draw the built-in drawing that they can do. That's either true or false. So our bounding box is we get the data from that, and have a bounding box, and then we can, Paul showed us how to do this top left and bottom right. All that was shown by Paul. And then we're putting it into those tuples into a my faces list, BB list. We're appending it to it. And each one of these is a tuple, and we're appending a tuple of those in there. So it's a tuple within a tuple within a list. So we got quite the data structure going on. And then we're just returning that data structure into our code, just like we've been doing for the rest of them. So I can show you how that works over here. And this is my basic code that I have for hand landmarks, pose, and now I add the face. This line here for face. So we're just making an instance of our class, and it's coming from our module MP help and face BB box. So doing that. And then these 3 lines of code here, what we need to get out to get the information to draw our rectangle. So we get our get array out of this, or our get data, our face BBs. And I set it up so it doesn't do the internal one, that we're passing the frame that we get here to it. So and then we just work through our boxes. It's called face B boxes, and we're getting for each one in there, we're just drawing a rectangle around that. And it's kind of cool because we're looking, your CV2.rectangle is looking for a tuple here of two numbers separated by a comma. And this face BB 0 element is the first one we need. That's actually returning a tuple, and the BB1 second element's returning another tuple for the end of it. So we're able to make it show it just that easy. Rest of it's our basic code. So we'll show it running. So we're getting, this is on my faster computer, we're getting 30 frames a second on it, showing that. And, I didn't have anybody else, but I do have a picture of my son and his baby girl. So let's see. The child doesn't want to come out too much. It must not be trained on children. I can get it to come in just barely. All right. So it can pick up multiple faces, and it stays at about 30 frames a second on that. So that's kind of cool. So quit out of this. And I also have the pose and the hand array. We can add them all together and see what kind of frame rate we get with that. This is just doing the built-in. It's not doing, it's bringing back the hand and the pose array, but we're not doing anything with it. We're just using the built-in functions that we're able to use. So as you can see, you're getting two sets of hands, you're getting the pose array, and you're getting the bounding box all in one. Still getting 18 frames a second, so that's not too bad. I'll quit out of that. So frames per second, I decide we're putting everything in a class. Let's go ahead and make a class for that. So actually, well, we can go through this. So I got my faces, I got my pose, and I got my hand array class in there. And then down here at the bottom, I made a class called MP track frame FPS frame per second. So we're just a lot of this will look similar. It's a little bit more involved than what we normally do on our screen, but we're initializing it and we're bringing in a data weight. I call it data weight. So that's our number, like 5%. So it's 0.05 we're bringing in. You can bring in whatever you want. So that's the only, when we initialize it, we'll tell it what data weight we want it to use. So we can pass that at the beginning. And then each time through the while true, we run the get frames per second, and it goes through this bit of code down here. So if you notice, I create another state machine. So we got state 0, state 1, state 2. So the first time through our code, we don't have a last time, or we don't have an average. So we just return 0 for the average, and we initialize get our first reading for last time. So the first frame's not going to show, but that's only the first frame. The second time through, we have we have our last self.last time, so we can get our delta time and create our frames per second, 1 over delta time for frames per second. But at this point, we don't have any averages to look at, because this is a sample of 1 and you can't average that. So we're just, instead of saying that this is frames per second, we're just making this the average and then increasing the state. We're up in the state. So the third time through, it's going to do this section here. And this is our base code for doing getting our delta t, turning it into frames per second, and then using our weighted average or low pass filter here. And then whichever ones of these it does at the end, it's going to return the average. So it's going, first frame is going to be 0. Second time it's going to be whatever sample of 1, and then the anytime after that, it's just going to return your weighted average. So that was kind of cool. And then back over here into the, when we're putting our text, to get that number, it's going to come in as a float. And we just call that function inside of here where we normally would put a number and or a variable, and it's FPS dot get FPS. So the FPS, I initialized it up here, and like I said, I passed in 5%, 0.05. So that's the weighted average, and it's instance is called FPS. So to call that method get FPS, at FPS dot get FPS, and then you have to put the open and close parentheses, and that worked out well. And don't have to have all those lines of code trying to tell you what to do. You just know that it's frames per second, and we can get it out of the helper library and clean up our main code some. So that's the whole deal with the classes and putting them in a different module, as it cleans up our code. So that's very interesting to me, and see how things happen that way. So I also did this in my portable, my little mini computer that I hope to turn into a mobile platform fairly soon. We can run the same code and show you that it's not as fast as my i5 laptop, but this is the same code that we had on there that was running 30 frames per second. So with this one, I'm getting about 14, 15 frames a second. So it's about half as fast as the other one. So I'll have to keep that in mind when I develop my mobile platform for sure. So quit out of that. All right. Well, I do want to thank Paul for all he does and everything. He keeping us busy learning all these things, Python things, and look forward to what he has next, and also look forward to you guys posting your homework as well. Talk to you all later.